All right. Good afternoon, everybody. Um, Hopefully, the stream is coming through live, right? I'm just trying something here on Facebook, right? As well as I'm trying to stream to multiple platforms at the same time here. All right. Um, so, welcome. My name is Terry David, for most of you who don't know, right? Um, I'm an electrical and computer engineer, right? I also hold a degree in management as well as a master's in business administration, right? I am also a past national scholarship winner from a long time ago, right? Um, I placed 7th in the country in sciences, right? And I got the highest mark in A-level chemistry. At that time, we did Cambridge, we didn't do CAPE, right? Um, I'm also the author of several books, right, that you might be familiar with, right? Those of you doing A-levels, right? So I wrote the official study guides for CXC, right? That's Cape Physics Unit 1 and 2, all right? It took me about 2 years to complete those books, right? And it's because of how I know how to analyze and interpret questions and to know what the examiners are looking for, right? This is why I wrote these 2 books, right? Initially, when I was writing the books, they were being written for Cambridge, right? But then I saw an opportunity with CXC, right? There wasn't any Cape physics resources at the time, right? And I've also written some other books here for Collins as well, right? A physics workbook, a maths workbook, and also a multiple choice workbook. All right. Now, today I'm just gonna give you a demonstration of how my live classes operate online, right? So basically, I have my own platform, right? I have my own website as well, right? And from this website, students get access to all my e-learning material, right? And that includes the notes, that includes the quizzes, the exams, right? And those kinds of things, as well as the links to my live classes, right? All of my live classes are actually recorded, so the students can go back to those live classes if they didn't fully understand something, right? Also, with respect to the live classes, so I give CSEC Maths, right? Physics as well as chemistry, right? Right, and these classes, well, I've posted the schedule many times for these classes, right? Now, the cost per month, right? Students, parents have been asking about the cost per month. So all my classes or each subject is 200 TT per month, right? It's 200 TT per month. Now, this gives you access to both the Form 4 and the Form 5 live classes, right? Which means that instead, if you're in Form 5 and you missed a lot of classes during COVID, right? You would get access to all those things, right? So if you missed out a lot of work in Form 5, then you will get access to the Form 4 live classes as well at the same price of $200. All right. Now, what I'm going to be looking at now is an examination question here for CSEC Physics, right? So this paper is from June 2011. All right. And the question goes like this. A taxi driver was taking his friends to a popular 2020 cricket match. Right? Table 1 shows the vehicle's velocity for the first minute of the journey, right? Now, you need to look carefully and see what information is being given here, right? So don't confuse the two. In this question, we have velocity on the left-hand side and we have time on the right-hand side. Velocity is being measured in meters per second and time is measured in seconds, right? And what they want us to do for 7 marks here is to plot a graph of velocity against time, right? So whenever you see in physics, they say plot something versus something or something against something, the first quantity, right, in this case is velocity, is going to be my y-axis or my vertical axis, right? So whenever you see versus, right, the first quantity before the versus has to do with my y quantity or my vertical quantity, right? Which means that I'm going to plot velocity in meters per second because quantities usually have a unit, right? And we have time, and in this case here, time is measured in seconds, all right? So what you're gonna do for this particular graph here, now because of how the table is written, right, it could be very confusing to the student, right? Because when you are plotting, you plot your x values first, and then you look at what your y values are, right? So the first point that we're going to plot here, right? So you need to make sure you know what you're plotting. It's 0.0 against 0.0. That's my first point, right? Now my second point here, you need to be careful because time is on the right hand side. So my second point will be 10.0, right? That's my x value. And my y value is 11.0, right? So some students, they had a little problem with this because they plotted the wrong thing, right? So time again, this is 20.0 seconds. So this is 20.0, right? And this here is 23.0, right? And we continue doing that. So you're going to plot each of these points on your graph paper, right? So typically in the exam, what they do, they give you a graph, and you're going to have to choose the appropriate scale in order to plot the graph, right? Some things to remember when you're plotting these graphs is that you have to maximize the space that is given to you. You don't want to draw a graph that is extremely small and in one corner of the graph, right? So your graph needs to be centered. You have to choose the appropriate scales, right? And when I say appropriate scales, you can use 1 unit or 1 centimeter to represent 1 unit, or 1 centimeter to represent 5 units, or 1 centimeter to represent, let's say, 2 units, or 1 centimeter to represent 10 units. We don't use scales like 1 centimeter represents 3 units, 1 centimeter represents 7 units. Those scales are difficult to read, right? So with this information here, we can plot a graph that looks something like this, right? So our first point was 0, 0. All right, that was our first point that we plotted, and that's here. This is the point 0, 0, right? The second point that we had to plot was 10.0, 11.0, right? So our second point was 10.0, 11.0, right? Now, remember, you need to label your axes. So notice I have time in seconds here. And on my vertical axis, I have velocity in meters per second, right? So I'm plotting the point 10, 11, right? So this is my 10 here, right? And I need to find where 11 is. So 11 is somewhere around here, right? And what you're going to do, you're going to keep plotting all the points from the table, right? And as you realize, you're going to get a straight line. So you're getting 7 marks for this, right? So there are certain things that CXC will be looking for here. So this is 7 marks, right? So you're going to get marks for labeling your axes, putting the correct unit, right? On both sides, the X and Y. You're going to get points for plotting the points accurately, right? So you're going to get marks for that. Make sure we plot the points accurately, right? You're going to get a mark for drawing your line of best fit, right? When you're drawing your line, you need to draw the line such that it passes through most, if not all, your points. All right. You're also going to get marks for choosing an appropriate scale, right? So in this case here, I've used 1 centimeter to represent 10 units on both axes, right? Now keep in mind that when you are plotting graphs in physics, right, you do not necessarily have to use the same scales for both axes, right? So that's my answer for part A. Let's look at the second part of the question, right? Now, what we've plotted here is a velocity time graph, right? And from the graph, they want us to calculate the slope. Now, with respect to question 1 in your written paper for physics, right? That question, you typically have to plot a graph, right? And that question is worth 25 marks incidentally, right? That's a lot of marks compared to the other questions that are only worth 15 marks, right? So some attention needs to be paid to this particular question, right? Now, they want us to find the slope. You need to remember, how do we find slope of a graph, right? Now slope, now they're calling the slope P, so we're going to use the same notation that they are using, slope P, right? Now from your maths, you should know that slope is y2 minus y1, y2 minus y1 divided by x x2 minus x1, right? That's the formula we're going to use for slope. Now, here's what we need to do. When you are finding the slope, you need to choose 2 points on the line, right? Now, I'm going to advise you, please do not choose a point that you plotted, right? Because those are experimental points or data that you have collected, right? So what you need to do, you need to choose 2 points on your line such that they are more than half the length of the line. So the 2 points that I have chosen is this point here, right? Let's call that point A, right? And I've chosen another point here. Let's call that point B, right? Now, what you need to do, you need to write down the coordinates of these 2 points, right? So the point A, the coordinates in this instance here will be, let's see, that is 10, 12, that is 12, right? So that point is 12, and that's 12, 14, right? And then the point B is going to be 52, 54. So this here is 54, and my next value here is 62, right? So you need to read off those 2 coordinates or those 2 points that you choose in order to find the slope, right? Now, the next thing, what I usually advise my students to do is to label these values, right? So for example, let's call this here x1 and let's call this y1. We're going to call this x2 and we're going to call this y2, right? Once you've done that, all you need to do is to substitute into the formula for slope. That's all you need to do, right? So here's what we're going to do now. We are going to just substitute into the formula. So y2 in this case here is 62, right? y2 is 62, right? Minus y, oh, sorry, I just realized I labeled something wrong here. This is x1, y1. This is y1, sorry, right? So y2 minus y1 will be 62 minus 14 divided by 54 minus 12. So this is 54 minus 12, right? And what you're going to do here now, we're going to use our calculator. So this is 62 minus 14. What you're going to get here is 48, right? And then 54 minus 12 is equal to 42. So this is 48 divided by 42. And what you're going to get here, or what I'm getting, is 1.14, right? Now, when you are given, when you're finding gradient, right, typically we must give it a unit, right? Now, here's what's happening here. My y values are given in meters per second, and my time values are given in seconds, right? So what I'm doing here, I am dividing, you're dividing meters per second divided by seconds, right? And that's going to give me meters per second squared. So my unit here is my unit will be meters per second squared, right? So it's 1.14 meters per second squared, all right? Right, so the question, now you should know from a velocity time graph, if I find the slope or the gradient, what I'm really doing here is finding acceleration. So notice in part C, that's what the question is asking. What quantity does the slope P represent, right? This is a velocity time graph, and I just worked out the gradient or the slope of that line. So what that actually gives me here is my acceleration. So my slope, right, actually tells me what my acceleration is, right? So that's what this is. So that is part B and part C, right? And by the way, if you're wondering what paper is this is June 2011, right? Now, the question now says, for the next minute, the vehicle's velocity was constant, right? So for the next minute, so remember, a minute is 60 seconds, right? So for the next 60 seconds, right, the velocity is constant. So far what you've drawn this. So you've drawn V in meters per second versus time in seconds, right? And you did a graph that looks something like this. This was 0, right? And we had plotted for the first 60 seconds, right? And our highest velocity was, let's go back to the table here. Our greatest velocity was 69 meters per second, right? So this value here corresponds to 69, right? And what they are telling us for the next minute, what that means is for the next 60 seconds, so you're gonna add the next 60 seconds here, but you're traveling at that same 69 meters per second. So therefore, this time here is going to correspond to 120 seconds, right? Because you covered 60 seconds initially, and in the question they're saying for the next minute, you travel at a constant velocity, right? So this flat line here, or this horizontal line, represents constant velocity. That's what this represents, constant velocity, right? Then they said for the final minute, again we're talking about a next 60 seconds again, the final minute, the vehicle decelerated, so it decelerated uniformly to a stop, right? Which means that what's going to happen is that your velocity is going to do this, it's going to decrease, and we add in the next 60 seconds. So when we add the next 60 seconds here, what you're going to end up with is 180 seconds, right? So this is a sketch of what the velocity time graph should look like. So in part 1, they said continue the velocity time graph to show the information and use the graph to determine the total distance traveled, right? So I've done a sketch here, right? But in the exam, they would have given you the graph paper. So what you would have had to do is to complete the graph, which is what I did here, right? So notice we started at time t equal to 0 and we finished at 180 seconds, right? So this is the answer for that part. This is how the graph is supposed to look. Now, the question is asking, use this information to find the total distance traveled, right? Now, total distance traveled is determined by finding the area under my velocity time graph, right? That is something you guys need to know. Now, there are two ways I can find the distance travel, the total distance travel. I can break up this shape into multiple shapes. So this could be one area here, and I'm going to call this A1. This is A2, and this here is A3. So you have two triangles and one rectangle. So to find the total distance travel, right? So the total distance travel is equal to the area A1 plus the area A2 plus the area A3, right? Now, A1, that's a triangle, right? So to find the area of that, it's a half multiplied by my base, which is 60, multiplied by my height, which is 69. So that will give me the area A1. Plus, we need to add the area of A2. A2 is a rectangle, right? The base of this rectangle here is 60 and the height is 69, right? Plus, we have to add the third shape, which is the triangle. So again, this is a half multiplied by 60 multiplied by my height, which is 69, right? Which is identical to the first triangle actually. So let's work that out. So that is 0.5 multiplied by 60 multiplied by 69, and you're gonna get 2070, right? Plus 60 by 69, you're gonna get 4140, plus when we work this out, you're gonna get the same 2070 plus 2. And what I'm getting here is 8,280. So I'm getting 8280 meters, right? So this is one way of working out the total distance. Now, some students, what they could do as well is to assume that shape is actually a trapezium, right? So total distance travel, right, could be found. There's a formula to find the area of a trapezium, and that is half the sum of my parallel sides multiplied by the distance between those parallel sides, right? So if you never saw this formula before, right, this is what a trapezium might look like, right? You have two sides which are parallel. Let's call that A, let's call this B, and let's call this H, the distance between those two. So the area is given by this formula here, right? So that's what we're going to use. And let's see if we get the same answer. So it's a half multiplied by, let's use A as 60, that's the height on top, plus the height below, which is 180, multiplied by my 69, which is the height. All right, let's see if we get the same answer. If not, well, then I made a mistake. 60 plus 180 multiplied by 69 multiplied by 0.5. Nope, we got the same answer. So we got 8280 meters, right? So notice this answer here and this answer here, it's the same, right? So we have two ways we can work out the distance traveled from a velocity time graph. You can break up the shape into two triangles and a rectangle, or we can use the formula for the area under, or the area of a trapezium, right? All right, so I'm seeing some of my students here in the chat, right? Hi Vishal, hi Liana. All right, so like I said, this was the answer for question, right? So this was the other part. Now the next part of the question here, they want us to calculate the average velocity of the taxi for the complete journey. Now there's a formula for average velocity, right? And by the way, if you are doing CSEC maths, you need to know this formula as well. So average velocity, right, is equal to my total distance traveled right, over my total time, right? So my total distance traveled, you just work that out. You got 8280. So this is 8280 divided by my total time. Now your total time is found from this graph. The actual time taken for this entire journey is 180 seconds, right? So therefore, all I need to do is to divide this number here, 8280 divided by 180, right? And what you're going to get, 46 meters per second, right? That's my average velocity for the entire journey, all right? So average velocity is equal to total distance over total time, right? Right, so what we have to do here now. Okay, so in this part of the question, if the total mass of the loaded taxi was 1500 kilogram, determine the momentum of the vehicle when it's traveling at constant velocity. So you all need to know that momentum, right? We usually use a P to represent momentum. Momentum is the product of a body's mass and velocity. So they told you what the mass is. It's 1500 kilograms multiplied by my velocity. They said when the velocity was constant. If you go back to the graph indicates that the velocity was constant at 69 meters per second, right? So what we're going to do is say 1500 multiplied by 69, and that is going to give us, so it's 1500 multiplied by 69, and you're going to get a kind of biggish number here, right? 103,500, right? And remember that we're talking about momentum here. Momentum, the unit we're going to use is kilogram meters per second, right? That is how we find momentum. It's mass multiplied by velocity. Mass needs to be in kilograms and velocity needs to be in meters per second. All right. Now let's see something here. Right, so that actually takes you to the end of question 1, and again that is 25 marks for that part of the question. All right. So like I said, right, so I usually give CSEC physics and CSEC chemistry as well as CSEC maths lessons, right? Anyone interested, you can contact me. You can send me a WhatsApp at 868-784-2059. Right, and this is me. All right, and like I said, once you sign up for any one of these subjects, right, you get access to both classes. So it's as if you're paying one price to get access to both a Form 4 class and a Form 5 class, right? So I'm going to do one more question here before I end the stream, right? So, oh, I didn't realize there was another part of the question, right? So this is still question 1. Didn't realize that, right? So the question wants us to define the term displacement. Now, there's a difference between distance and displacement, right? And typically how I describe this is that, let's say we have some guys playing football on a field, right? And let's say one of the guys starts at the point A, right? And they start running all over the field, right? So they're running all over the field, right? And they end up at the point B sometime after. My displacement is actually represented by an arrow because displacement is a vector quantity, right? But this here, this whole loop that you see in here, this here is my actual distance traveled. So this is distance, right? Whereas this green arrow here is actually my displacement. So this here is displacement, all right? And displacement is a vector quantity. But when they ask you to define it, all you're going to say is displacement is the distance moved in a stated direction, right? So that's essentially what it is. It's a distance moved in a stated direction, right? All right, so I'm seeing somebody ask if I teach students outside of Trinidad. Yes, I do, right? All right, so here's what's going on here now. So they give us a table and they want us to identify what is scalar and what is vector, right? So we just spoke about displacement, and yes, displacement is a vector quantity, right? Distance is a scalar quantity. They want to know what is acceleration. So acceleration is also a vector quantity, right? So you all need to remember that scalar quantities have magnitude only, whereas vector quantities have magnitude as well as direction, right? So you have magnitude as well as direction for a vector quantity, right? Now, I'm going to do one more question, right? Because I have another class sometime later this afternoon, right? All right, so we have a table here, and they want us to insert the correct symbol and SI unit for the quantity in the column, right? So the first quantity we have here is specific heat capacity, right? So some students, they don't necessarily remember the unit offhand, but what you need to remember is this formula, which is energy is equal to mass multiplied by my specific heat capacity multiplied by my change in temperature, right? So you might see delta T or delta theta, the same thing. So therefore, specific heat capacity, small c, is equal to E divided by M multiplied by delta theta, right? So this here, energy is measured in joules, right? And I'm dividing that by your mass here, which is kilogram, and you're multiplying that kilogram by a change in temperature, right? So the change in temperature might be measured in in degrees Celsius, right? So therefore, my unit that we can use for specific heat capacity is joule per kilogram, right, per degree Celsius, right? You might even see the unit written as joule per kilogram, right, per Kelvin, right? So my SI unit in this case here will be joule per kilogram, right? And we can use per Kelvin, right? Because it's that SI unit. The SI unit for temperature is actually the Kelvin, right? The next unit that they want is specific latent heat of vaporization, right? So the symbol that we use for latent heat of vaporization is actually given by a lowercase l, right, with subscript v, right? Now the formula that we use to find latent heat of vaporization is m multiplied by lv. So lv is equal to energy divided by mass, right? Energy is measured in joules, and I'm dividing that by mass, which is measured in kilogram. So therefore, my unit is joule per kilogram, right? So this here is joule per kilogram, all right? Right, so that's it. 3 marks just for completing this table, right? So this is on thermal physics, right? Now, the next part of this question here, part 2, they want you to define heat capacity of a substance. Now, there are 2 definitions you have to know, and that is specific heat capacity and heat capacity. So heat capacity, right, which is actually a big C, capital C, right, is the energy required to increase the temperature of a substance by 1 degree, right? So do not confuse this definition with specific heat capacity. What they ask us for here is heat capacity, right? Which is a different definition, right? And it's a capital C. Now, in the third part, they want us to write an equation that relates specific heat capacity to heat capacity, right? So you need to know this. You have specific heat capacity, which is capital C, and then you have, totally wrong thing there. Specific heat capacity is a small c, and heat capacity is a big C. So they want us to write the relationship between these 2 quantities, and the relationship is this: big C is equal to m multiplied by small c. So this is my relationship between specific heat capacity and heat capacity. So the big C, right, the big C is what we call heat capacity. So this here is heat capacity, right? And this here is specific heat capacity. Right? So that is the third part, right? Now the next part here now, right? We have, let's see what they're saying here in part B. You have a busy housewife, and she left 25 grams of ice in an open insulated container, right? So she has some ice in a container. So it could be an ice and styrofoam cup or something, while she was answering her cell phone. When she returned, the ice at 0 degrees was converted to water at 3 degrees Celsius. Question 1. Calculate the energy needed for the ice to totally melt to reach its present temperature, assuming no heat losses. Right. So a question like this is worth a good bit of marks, right? And you need to be careful how you working this out. Now, typically how I teach this, right? I need you to understand and visualize what's happening. So we're starting off with ice, right? And if you read the question carefully, they told us that the ice was initially at 0 degrees. So we're starting off with that. We start off with ice. So you have a block of ice here, or some ice, right? You started off with 25 grams, right? So M is 25 grams. But keep in mind, if we look at our units they've given us units that have kilograms in it. So just keep in mind that you're going to have to convert this into kilograms, right? So we have ice here, and the ice here is at 0 degrees Celsius initially. Now, that ice is being converted into water at 3 degrees Celsius. So in your mind now, you need to understand what's happening. So you have ice at 0 degrees. The first thing that's going to happen is that ice is going to be converted into water at 0 degrees. So that's my first step. I'm going to convert that into water, but that water is going to be at 0 degrees Celsius. Now, whenever you have a change from one phase to the next, right, the formula that you need to use is this. E is equal to MLF, right? When you're going from solid to liquid, we have to use E is equal to MLF. Notice something here though, that my ice is at 0 initially and my water is at 0 degrees Celsius, right? So that's first phase that's taking place. Then now we have water at 0 degrees, but we need to increase the temperature of that water to 3 degrees Celsius. So we have our next stage that is taking place here now. So what's happening here is that that water at 0 is going to be converted to water at 3 degrees Celsius. So this is 3 degrees Celsius here. So there's an exchange that's taking place. However, all we're doing here with the water, we're not undergoing a change in phase. What you're doing is undergoing an increase in temperature. So the formula that we have to use is E is equal to MC delta theta. That's what we're using. E is equal to MC delta theta, right? So let's see. So now the question wants us to calculate the energy change to totally melt this, right? So the assumption we're making here is no heat losses. That's typically our assumption. So I need to find out two energy changes. I need to work out what is this energy change here, and I need to work out this. And when I get those two answers, I'm going to add it, right? That's what I'm going to do. So let's do the first part. I'm going to do that first part up here. So E is equal to MLF, right? Now keep in mind, CXC typically gives you a mark for writing the formula that you intend to use. They give you a second mark for substitution, and then you get a mark for the final answer. So my mass here is 25 grams. You're going to convert from grams to kilograms. So I'm going to have to divide by 1,000. So this is 0.025. So this is one point where students typically make a mistake. They don't convert the grams into kilograms. Now to know if to convert or not, you need to look at the unit they've given us. So if you look here, they've given us our latent heat of fusion in joules per kilogram, which means I have to work in kilogram. So this is 0.025 multiplied by 340,000, right? That's the latent heat of fusion of ice, and you work that out. So that is going to give me 0.025 multiplied by 340, 1, 2, 3. And what I'm going to get here is 8,500. 8,500, we are working out energy, so that has to be joules. So this is my first energy change here, all right? That's this energy change here. The next thing we're going to do now, we're going to do the second energy change, right? And let's work that out. So the formula we know we're using for that one is E is equal to MC delta theta. My mass in this case, I have to work in kilograms, so it's 0.025 multiplied by C. So C for water, the specific heat capacity is 4,200 multiplied by my change in temperature. The ice, look at my change in temperature here. You're going from 0 degrees to 3 degrees Celsius. So therefore my temperature change is actually only 3 degrees Celsius. So that is 0.025 multiplied by 4200, put an extra 0 here, multiplied by, let me just work that out again. So 0.25 multiplied by 4200 multiplied by 3. And what I'm going to get here is 315 joules, right? But that's not my final answer, because the question said, what is, calculate the energy needed for the ice to totally melt and reach to the present temperature, right? So my total energy required to do this, all I'm going to do is to add those two numbers. So it's 8500 plus 315, all right? And what I'm going to get here is 8,815 joules, right? So I'm assuming this answer is correct. And this, I think, is the last part of the question. They said if this melting and heating activity took place over 300 seconds, calculate the rate at which the ice water was receiving heat. Now, you just worked out the total energy required to convert the ice into water. That's 8,815, right? So my energy is equal to 8,815 joules. That's how much energy is required to convert my ice. So remember I started off with ice at 0 degrees Celsius, and what you ended up with was water at 3 degrees Celsius, right? And you want to work out the rate at which, so once you see the word rate, right, what they're really asking you for here is power, right? And power, as we know, should be energy divided by time. So your energy, you worked that out before, that's 8815 divided by my time. They told you the time taken to do that. It's 300 seconds. So this is 300. So that's 8815 divided by 300. So what I'm going to get is 29.4, right? And you can give your answer as watts, or you can say 29.4 joule per second, right? So, or 29.4 joules per second, right? But we know that joules per second is actually watts, right? So that brings us to the end of two questions here, right? Related to thermal physics as well as mechanics, velocity time graphs, all right? So like I said, anybody who's interested in CSEC physics, right? So all right, you can contact me at 868-784-2059, right? So you can send me a WhatsApp if you want to get further information, right? Especially those who are writing exam in May 2021, right? If you join the class, you get access to both the live Form 5 and the Form 5 classes at one price, right? So both classes at one price, right? With respect to the Form 5s, we are almost finished with the syllabus, after which I'm going to be focusing on examination questions and how to answer questions in order to maximize your marks, all right? With respect to the Form 4s, we're almost finished with the mechanics section, right? We just have Archimedes principle to do, and that's it for mechanics. So we're going to be doing examination questions from now to the till the second week in December. All right. So I hope you all enjoy the video, right? For those of you watching live on YouTube, you can click like and subscribe. Please feel free to share the video. All right. Those of you looking at it on Facebook Live, right? Just click like and forward the video. All right. So that's it for me, guys. I hope you enjoyed the video. Right? Take care, everybody.